Okay, hello friends, welcome back to my channel on statistics on average row. So right now we are in the engineering mathematics playlist. So in the last lecture I have given brief about playlist and how many modules will be there and what are the concepts we are going to discuss and everything. So now I am discussing about lecture 2. So in the lecture 1 I have given basic definition of matrix and what are the operations you can do on a matrix and with some examples and some inverse determinant, how to find inverse and determinant for 2 cross 2 and 3 cross 3. We have done those things. So in this class I will discuss about elementary operations. Okay. So what are the operations? Operations are nothing but addition, subtraction, multiplication and division. Okay, so how you can apply these type of operations to rows and columns basically. So there are some three basic rules are there for this, and rule one is you can interchange or replace any two rows or columns. You may replace two rows or two columns, means from swapping row 1 to row 2 and row 2 to row 1 like that. And second one, you can multiply or divisible. So it's nothing but you can multiply or divisible with any scalar except 0. Okay, you know, if you apply with 0, what will happen? You will get everything 0 0 0. So there is no use of doing that thing. Okay, third one is nothing but addition and multiplication combination both, but say or subtraction or multiplication. Let's say you want to modify r1 to r1 plus 2 into r1, something like that. Okay, so what is the use of doing those things? Basically, by using as elementary operations, you can reduce the calculation. Means you can convert your matrix into, for example, we are having 12, 12, 13, 14 with the huge numbers. You can convert those things into single digits by applying some operations. Then you can apply whatever matrix. For example, you want to find system of linear equations or rank. It will be the simple. Okay, we will see some examples here. For example, we are having a matrix A equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see there is no any divisibility possibility will be not there. So let's say I want to interchange R1 to R3. Okay, so then what will happen? 7, 8, 9, 4, 5, 6 will be the same, and 1, 2, 3 like this swapping. Similarly you can swap column also. So for example, I want to swap C1 to CO2, then what will happen? 2, 5, 8, 1, 4, 7, 3, 6, 9. So now you can observe third column will be divisible by 3. So you can do that also, C3 by 3. So then what will happen? 1, 2, 1, 5, 4, 2, 8, 7, 3. Okay. Next, for example, we are having matrix 1 2 1 5 4 2 1 8 7 3. Now I want to reduce this 5 into 0. For example, I want to make it as an identity matrix. What is the next step in that? It's nothing but R2 implies R2 minus 5 times R1. Okay, so then what will happen? 1 2 1 0. Similarly, it will apply for complete row, not only for single element. So when you multiply with this 5, 10 minus 6 and 5 minus 3. And similarly, 8 7 3 will be the same. Okay, like this you can apply elementary row operations or column operations or whatever it is. So what is the use of these things? Since I already explained. So next concept, row reduced echelon form. Okay, so in these two forms will be there. One is row echelon form, another one is row reduced, means row reduced echelon form, RREF. Echelon form means you should be in the any one of those things. So now again, for any matrix satisfying for row echelon form or row reduced echelon form, some properties are there. First we will discuss about row echelon form, then we will move to row reduced echelon form. Okay. First we will see row echelon form. Okay. So it's nothing but there are some properties are there. So property number one, all rows consisting of only zeros, only zeros are at the bottom of the matrix. Means, for example, we are having a zero row, it should be in the bottom. For example, I am having this example. So now it is in the, now here it is satisfying first property. Similarly, if I have one more example, 1 2 0 0 2 1, so here it is violating the first rule. Why? Because if there is any complete zero row, it should be in the bottom. Okay. And again, in row echelon form, you have right to apply only row operations. You don't have right to apply column operations. On second property, leading entries means non-zero entries of a row is always strictly right. If of a row is always strictly to the right, means it should satisfy the upper triangular property. Okay, now I will tell you some example. For example, we are having a 1, a naught, a2, and so on, an. Similarly, 0 1, a1, and so on, a2, and 0 0 0 1, and so on, a3, like this. Here not only one, here it can be any scalar. For example, here it can be any scalar. Okay, now we will see some examples on this. Let's say we're having matrix 1 0 0 1 0 0 0 1. You can see here all leading coefficients starting with some scalars. Okay, and again it is satisfying strictly right property. It means upper triangular property. Again, for example, you are having one more matrix 1 0 0 and 0 0 1 and 0 1 0. What about here? Here non-leading coefficient starting with some scalar, here also some scalar, here also some scalar. Again, if you see the relationship, here C1 is there, next C3 is coming, next C2 is coming. So here it is violating. So it is not form of row echelon form. Similarly, if you see one more example, let's say 1 0 0 and 0 1 0 and 0 0 1 and 0 0 1 0. What about here? Some of them, how they will say, na? Here it is upper triangular property satisfying, na sir. Why not it is row echelon form? That's why you should make sure about this condition. C1 here, C2, then C4, then sorry C3. Here C4 will come here. Here C3 will here C3 will come here. C4 will come. So here it won't satisfy. So wait once again. So 1 0 0 and 0 1 0 0 0 0 0 1 and 0 1 0. Okay, you can see here C1 and C2, then here C4, then C3. So here it is not satisfying. Here it should be C3 and here should be a C4. Okay, like this. And if you want to some more examples, I will write some more examples here. For example, 1050 and 00000105. What about this? Again, it is the not form of row echelon because this zero entry should be in the down, means it should be, if you replace R2 implies R3, then it will become row echelon form. Okay, so I hope this concept will be the simple. And coming to the row reduced echelon form, there are two more extra properties will be there. We will discuss that one here now. Next one, row reduced echelon form, RS RREF. Okay, and coming to the properties, first property, second property will be the same like row echelon form. So all non-zero rows should be at the bottom and leading coefficient should follow strictly right in subtle triangular property. And third one is always non-leading coefficient should start with 1. Okay, so earlier case it is any scalar, but here it should be start with 1. And fourth one, if any row non-zero loading coefficient 1 presents, then corresponding column values above and below should be zeros. Okay, so these all are the properties. Now we will see some examples for this also. Okay, let's say you are having matrix. First I will write down that property here. So 1 0 a1 and 0 b1 and 0 1 a2 0 b2 and 0 0 0 1 c2. It will be in the form like this. You can keep any scalars. See here, always leading coefficient, non-leading coefficient, non-zero leading coefficient should start with 1. Here it is starting, here it is starting, here it is starting. Okay, and again if there is a 1 non-zero leading coefficient, then corresponding columns should be zeros. Here also 0 and here also 0. Okay, now we will see some examples here. Now let's say we are having one more matrix 1 0 1 and 0 1 3 0 0 0. Now you can say it is row reduced echelon form. Why? Because it is starting with 1 and here 1 and this forgot about this row, it is in the bottom. Okay, now one more matrix. For example, you are having one more matrix 1 0 0 0 minus 2 0 and 0 0 4. What about this case? So here first row no problem. Coming to the second row, here minus 2 is there. When I make it this one as a 1, it will become row reduced echelon form for second row. What about third row again? So when you do by these operations, then you will get row reduced echelon form. Okay. Similarly, let's say we are having one more matrix 1 0 0 and 0 0 1 0 1 0. You can see this matrix, it is not row echelon form, you can say, and of course it is not row reduced echelon form also. Why? Because all properties are satisfying except upper triangular property. Okay, so here c1 is there and here c3 is there and here c2 is there. Okay, so we will solve some examples to reduce from the given matrix to row echelon form. Okay, let's say we're having matrix. So A equal to 3 1 1 and 5 1 2 4 2 7. Okay, now we want to reduce this matrix into row reduced echelon form. So how you can do? And you know that always non-leading coefficient should start with 1. Okay, so here only it is nothing but you need to convert this matrix into 1 0 0 0 1 and 0 0 1 identity matrix. Okay, so how you will do that? So if you want to make 1 here, either you can apply r1 by 3 or else r1 implies r3 minus r1. Okay, it will be just simple. Why? Because when you do this step, you will get by 3 and fractions and everything. So I will go with this step. So what you will get? 1 1 6 5 1 2 then 4 2 7. Okay, So what is the next step? Here we need to make 0, here we need to make 0. How you can make this one 0? R2 implies R2 minus 5 into R1, and R3 implies R3 minus 4 into R1. So then how it will become? So 1116 will be the same, and coming to the here 5 minus 5 0, 1 minus 5 minus 4, and then again here 30 will be there, 2 minus 30, it is nothing but minus 28. And again here when you do with multiply 4 with R1, 4 minus 4 0, 2 minus 4 minus 2, 24, 7 minus 24 is nothing but minus 70. Okay, so what is the next step? Here it should be the 1. So what you can do? So R2 divisible by minus 4. So it's nothing but 116 0 1 7 0 minus 2, or you can apply R3 by minus also, then it will get positive 270. Okay, so what is the next step? So here you want it to 0 and here you want to 0. So how you will get those things as a 0? R1 implies R1 minus R2. Similarly, R3 implies R3 minus 2 into R2, not R1. Okay, when you do R1 again here some term will come. So R1 1 0 and minus 1, R2 will be the same, and here 0 0, 17 minus 14, it is nothing but 3. Okay, so what is the next step? Here you need to make 0. So how it will become 0 gn 0 minus 1 0 1 7 0 0 1. Okay, now you want here as a 0 and here as a 0. How will you get this? R1 implies R1 plus R3. Similarly, R2 implies R2 minus 7 times R3. Then you will get 1 0 0 0 1 0 0 0 1. Okay, so like this you need to apply only row operations. You don't have rights to apply column operations. Okay, now we will see one more example with uh, let's say you are having 0 1 2 minus 2 4 0 2 6 2 1 3 1. So now we are having some rectangular matrix. Now we need to convert into row reduced echelon form. What is the first step? Here it should be the, means you can replace these two here, or else what you can do, yeah, that is the best option. Okay, so or else is there any other options you can see? See again, first of all, you don't have any problem. Why? Because already 0 presence is there. So we can, and non-leading coefficient starting with 1. So it is in the form of first row, no problem. And corresponding 0 is here. So if we make here 0 and here some, no, here also it should be 0, and we can make here 1. And now we need to make this one as a complete 0. So is it possible? So if you observe, we can make any one thing as a 0, but we cannot make other as a 0. So that no use. So you need to replace composite. There is no so R1 to R3 you need to do replace. So 2131 and 4026 and 012 minus 2. If there is two zeros, then we can do those things. Okay, so now how you will get 1 here? Of course you will get fractions here. So when you do R1 by 2, then it's nothing but 1 1 by 2 3 by 2 1 and 4026 and 012 minus 2. So here you want 0 means R2 implies R2 minus 4 times R1. Okay, so what will be the next step? So R1 will be the same 1, 1 by 2, 3 by 2, 1. And R2 here 0 we will get, and 4 by 2 means 2 minus 2. Similarly here 12 by 2, uh, 2 minus 12 by 2, it is nothing but 6 minus 4. And here 4 means 2. Okay, and 0, 1, 2 minus 2. 0, 1, 2 minus 2. So what is the next step? Here you need to make 0 and here you need to make 0. Or else if you make this one as a 1 and again here 0, here 0 and here you can make 1 and here 0, here 0. Okay. So we can go with any one step. Now if I want to make here 1, then what I will get? I need to divisible by 2. So 1, 1 by 2, 3 by 2, 1, 0, 1, 2 minus 1, and 0, 1, 2 minus 2. Okay. Now we need to make this one as a 0 and this one as a 0. So how you can make that one? So it is nothing but R1 implies R1 minus half into R2. Similarly, R3 implies R3 minus R2. So then 1, 0, 3 by 2 and 1 by 2. It's nothing but 1, 1 minus 3 means 1 by 2. And similarly here 1, 1 plus 1 by 2 is nothing but 3 by 2. So R2 will be the same, 0, 1, 2 minus 1, and here it will be a subtraction, 0, 0, 0, and minus 2 plus 1, here it will get minus 1. Okay. So what is the next step? So here already it became 0 now. So here we need to get plus 1 by multiplying those things. Now you need to make this one as a 0, this one as a 0. So when you do that, it will be done. Okay. In this way, you can do row reduced echelon form. Okay. So in the next class, we will see a lecture about rank of a matrix. Okay. Again, in a rank of a matrix, we need to apply again same row operations column, but there we have a freedom to apply any operations like row or column. Okay. See you in the next lecture. Thank you. If you have any doubts, you can comment.